Hello everyone, and welcome once again to Python Programming Fundamentals with Mr. Incongruous. Today I thought we would do something a bit different, and that we needed to change the format of the exercise videos. I realize it doesn't make a lot of sense for me to be just solving exercises willy-nilly, even if that can be helpful for you to start understanding the logic behind the decisions you have to take when tackling a certain small problem or exercise. So I thought about it better and came to the conclusion that it would be more beneficial if the exercises were all centered around a single topic. What I will do now is every week I will just Google and solve whatever exercises I find, focused on a single topic each time, following the same order as we saw on the text lessons that you can, as usual, find on the description down below. And so that way you can go and see what the current session is about and check how to solve exercises related to that specific area of Python programming. Today we will start with I think the very first thing we did in the lessons was the if and else statements, which is why we will start with those. Now let's see here, Python exercises for beginners, if else. Let's see what we come with. Okay, Python for loop and if else exercises. This sounds promising. Let's see what we get here. And we often use a loop and if else statement in our program, so a good understanding of it is necessary. Python loop quiz doesn't make a lot of sense for us. Now exercises is what we are looking for. Let's see. Exercise 1. Print the first 10 natural numbers using a while loop. Okay, let's come here. This editor is about a video I'm currently editing. It should go up on Thursday, about making a document editor using a special library. It's to be completely honest with you, it's way more work than I thought it would be, but it's okay. We live to learn. What were we about? Oh, print the first 10 natural numbers using a while loop, starting from 0 and ending at 10. We know that while takes a condition and checks if it is true or not. So the first thing we need to do is to have a variable that checks for that condition and work with that. Let's say a variable called number, which will be equal to 0. And we will say while number is less than or equal to 10, it should print the number. And very important, number plus equal 1, which is exactly the same as number equals number plus 1. I just use this nomenclature because it's a bit shorter, but if you feel like it's clearer for you and that you understand your own code better or it looks better, if you do it this other way, just go for it. As I've mentioned quite a few times, there isn't a single way of doing things with Python. Now, moment of truth. Let's see how this goes. F5 and go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is taking a little bit too much space. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just see their solution. They're just using I instead of a clear variable. That makes sense for these small exercises when you only have 1 or 2, maybe 3 variable stops. It's very easy to keep track of which variable is doing what. But as you go on to bigger projects, you will find it's much harder to know exactly what each variable does unless you give them a significant name like count or whatever. Exercise 2. Print the following pattern. This is the same. We are printing numbers. Okay. This one is interesting. Let's check. Oh, sorry about that. It's the wizard behind the curtain. Now, exercises. We want to print 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 5. We will start with the same. Count equals 1, while count less than or equal to 5. Yeah, there we go. Count. We will say phrase will be equal to count, but turned into a string. So it would be string count. Oh, and we will need a way to accumulate all the different numbers that we will be getting, which will be final word. Remember, this is just what I came across in this precise moment, so you don't need to follow my own nomenclature. This is just one way of doing it. Now, phrase is equal to the count starting on 1 turned into a string, which is important because now we will change the content of the variable final word. Final word is equal to final word, to which we will add the phrase. And finally, we tell Python that count is equal to count plus 1. So what should happen is that on the first loop, count is equal to 1, phrase is count turned to string. Actually, we don't even need this phrase. We can just go with final word is equal to final word plus string count and forget about phrase, which saves us a single line of code. Okay, what should happen on the first loop? Final word is an empty string. On the first loop, final word turns into a string with the content of which will be the first number. Count increases by 1, so on the second we will add the 1, 2, then 1, 2, 3, and so on. There is a small mistake here. We should print final word. If you want, you can pause this video and try to see what you think it is. Now let's execute it. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, which seems to be correct, except that here they mentioned that they want it with a space. And it's strange because the 5 doesn't have a space after it. This could be an error on the person who wrote the exercise, or it could be that we're meant to do something different. So, two options. In case they made a mistake and it doesn't matter whether the 5 has a space after it or not, we can just add a space. So each time it will go on. 1, 2, 1, 2, 3, 4, 5. Well, we can see it here that there's a space after the 5. And if we want to be very nitpicky and go, oh, but there isn't a space here, what we can do is add a couple more lines of code. While count, we just want count to go up to 4, and then is less than or equal to 4. The loop will break once count reaches 5, because 5 is not less than or equal to 4. And then we can say, let's keep the syntax we've been using. We could just go with print final word plus etc, etc, but it's better to be consistent. Final word equals final word plus string count, and then print final word. With that, we're going all the way just until the edge of the solution, and then with these two lines we add the final number, which will be the one to complete the series. We have seemingly the same result, but this one doesn't have the extra space at the end. This will probably seem to you like I'm being too precise, too fastidious, but in time it might prove necessary to make these subtle distinctions so that you get the results you want, and you can avoid getting mistakes in your code. It's a good policy to think about different ways that things could fail and plan for the most likely of them. And that way, if things fail, you know more or less what could have happened, and if they don't fail, you'll be pleasantly surprised. Let's check the solution they give. Show solution. Okay, second number pattern, last number. Okay, they went for a different route than the one we took. This is instead of using a while loop, they used a for loop. Okay, this goes with range, which is a function that prints everything except the last number. So if we say for range in 1 to 5, nope. Okay, for x in range 1 to 5, print x, it should print from 1 to 4. Okay, and that's why they, oh, sorry about that, why they say last number is 6, because they want to go all the way up to 5. And for row in range 1 to last number, they first from 1, then 2, then for 1, 2, 3, 4, 5, and for each column they would print the column, and instead, to avoid getting everything in many different lines, what they do is they use this parameter which tells Python that instead of finishing on a line break, which is what usually happens when we have many consecutive print statements, it should end the line with a space. So, which is how we get this result. Let's check it just to make sure everything is working as it should. And we are in exercises. Okay, and yeah, we know it was a mistake because the 5 actually has an extra character in it in the solution they are proposing. So I feel vindicated by this. Okay, and this is a great example of something that I've been telling you time and again, that there isn't a single way of doing things. As even in these quite simple exercises, two people got two absolutely dissimilar solutions, which nevertheless got to pretty much the same result. Okay, let's go to number 3. Accept number from user and calculate the sum of all numbers from 1 to that number. Let's see. Okay, so we need to it needs to sum all numbers up until that one and print the result. So if the user prints 1, the output should be 1. If the user inputs 2, it should be 3, and so on, which is something that computers are really good at. I wouldn't be able to calculate that, or at least not quickly. Yeah, we need to accept a number from the user, which means using the input function. We will say number equals to input, and we will give the user a prompt. Please enter a number. We will say that final number is equal to that number turned into an integer. And then let's go with the while root. We will say we need a result, which is a sum, so it should start with 0, and we need to go in a range from 1 all the way to that number. So let's go with, just to make our lives simple, for x in the range that goes from 1, but it doesn't go all the way to the number, because range always stops 1 short. We will say it should go all the way to final number plus 1. And result is equal to result plus x. So on the first one it should be 0 plus 1, and the value of result is 1. On the second it should be 1, the value of result, plus 2, which is 3. On the third one it should be 3, the value of result, plus 3 more, which is 6, and so on. And finally we should print the result. Let's see how this goes. First with what they said. Now we want the number 10, 55. If we enter the number 4, it should be 10. And we seem to be good to go. The only thing that is a couple aspects that could be of concern is what happens with negative numbers. How can we fix that? And what happens if the user doesn't input a correct number or enters a string? That is something for a bit more, for a topic that is a little bit more complicated, which is called exception handling. And it basically tells Python, try to do this unless you come across this type of error, in which case you should do this other thing. And so for example, in our case, it could go do this, enter a string, int, the number should be equal, try to turn it into an int, except type error, because if he enters the string Joe or whatever, Python won't be able to turn that into an integer. So if that happens, just print error, please input a number, and that way you avoid crashes in your program, which, depending on what you're doing, can be more or less important. Now let's see if the solution we got is similar to theirs. Yeah, well, they have a much nicer way of presenting things than I do. There's no denying that. But yeah, it's pretty much the same. Sum1 equals 0. That's the variable we called result. They put it at the beginning. N is the number, and they put everything in a single line. Int, instead of going with 2 more variables like we did, it directly turns the input, please enter number, into an integer. In this line, for I in range, again, like we did from 1 to n plus 1, this third parameter is telling Python that it should go in steps of 1, which is the default, so it's not strictly necessary, but sometimes you can decide you want to be very crystal clear about what you're doing. This one you can change in case you want to go only with odd numbers, so 1, 3, 5, 7, or from 3 by 3, or whatever you wish. Okay, sum1 is equal to sum1 plus I, which will start increasing, and finally print n. I wonder why they got this backslash. Let's check. There should be 2 print statements. Please enter number 10. Sum is 55. We're only getting the second one, sorry. Oh, this is where it prints a new line, which gives us a bit more space and makes it look a bit more professional, maybe, or easier in the eyes, which is something I didn't take into account, obviously. Now, exercise 4. Well, I just noticed that these we haven't found the if and else statements yet. Let's see if we can find one. Divisible. Okay, here we go. Given a list, iterate it and display numbers divisible by 5, and if you find a number greater than 150, stop the loop operation. That's quite a tall order. Let's see what we can do. We will delete these and start working around. We have here we have our list. List 1, remember, if we use list, it will probably give us an error. Oh, that's strange. Should you throw an error because list is a reserved word, but okay. List 1 it is. Iterate it, which means for each element, once again, element in list 1, we should perform operations. And that's one way of doing it. The other is using a while loop, which isn't as intuitive, which would be position equals 0, and while position is less than or equal to the length of list 1, print list 1 index number position and increase position by 1. I think this should print the elements. Okay, no, because it goes all the way, it goes off the map, so to speak. it goes with 0, 1, 2, 3, blah, blah, blah. And since the indexing starts from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means there are 11 elements. Number 11 will say, oh, this doesn't exist because it's going all the way up. Counting starts from 1, indexing starts from 0. So what we do to avoid that is just printing -1. And now, as you can see, it prints correctly. There may be situations where you will want to iterate through a list using a while loop, but as you can see, it's much more complicated than just using a for loop. So that's what we'll do. For element in list 1 and display numbers divisible by 5. If number to know if it's divisible by 5, it means that it should fit snugly within a 5, which is not a very scientific term, but I take that to mean that there's no remainder. There are no extra numbers, so 5, 10, 15, 20, and so on, which means that if number modulo 5 is equals to 0, we want to print that number, that element, sorry. And there is a different condition that we want to check. If you find a number greater than 150, stop the loop iteration. You could take that as if that you print it and then you stop it, or that you stop and you don't print anything else. In this case, the expected output is telling us 150 and it's not printing 180, so we know that it should immediately put an end to all operations. How do we represent that here? Is putting an element before the if that we got here. That should say if element is greater than 150. I think this is a new command that we haven't spoken about, which is called break, and this will stop the execution of the loop and continue outside of it. So print, just checking, and it should sorry, I get the the bad habit of pointing at the screen as if you could see it. If the element is greater than 150, it'll break, which means it will go all the way to the end of the loop and continue executing the program. Given the way that break works, there shouldn't be any problem with us having this and this as two separate if statements, but if you want, you can also use an elif statement. The result should be exactly the same. Let's see. Well, maybe I'm wrong. We have our result, and here we have the expected result: 15, 55, 75, 150. The just checking we was added by ourselves. And let's see what happens if we use our with two if statements, how it goes, and the result is exactly the same. Once again, one exercise, many ways of going through it. Let's see what they suggest. For item in list 1, if item is greater than 150, break. If item modulo 5 is equal to 0, print item. So their solution is pretty much the same as ours. Exercise 6. Given a number, count the total number of digits in a number. For example, if the number is 75,869, the output should be 5. There are many ways to go through it, but we've already been here for a while, so I'll go with a simple one, which is, I'm pretty sure you can guess it by now. Exactly, we will cheat. We say number is equal to 99,999. We need to know how many digits are there in the number. So in order to do that, we can just use the length, the len function, which would give us the length of the variable. But if we try to say print len number, we will get a nice error, because integer has no len. A number doesn't have a length, it has a quantity, an amount that it represents, which for Python are two completely different things. What we do then is, before trying to get the length of this number, we turn it into a string. Whoops, string number. And if I am correct, this should give us an output of 5. 5, if we add another digit, it's 6. Now, as you can see, we have 3 different sets of parentheses. So if we want to make this a bit simpler or easier on the eyes or easier to follow, in case we think that others might want to check our code or need to see how it works and so on, what we can do is say, instead of number to string is equal to string number. Then say number len is equals to the length of number to string, and then we print number len. The result is the same, but it could be easier for someone who isn't used to examining code. It's much easier to follow the logic if we do this than if we have the 3 sets of parentheses in one line. But in the end, you do you. All right, and we have time for one final exercise. Print the following pattern using a for loop. 5, 4, 3, 2, 1, which is the opposite of the first exercise we solved, or second, where we had to print this one, the second. Okay, 5, 4, 3, 2, 1. It doesn't. Oh, let's see if what their solution was. No, they did something more sophisticated by counting the amount of digits given the amount of times that you can divide it by 10, but the end result is the same. Okay. Print the following pattern using a for loop. In this case, what we are doing is starting from 5, 4, 3, 2, 1. So our starting number is equal to 5, and for each, let's try something. For element in a range, because they asked us for a for loop, in the range that goes from starting, let's just make sure, print range, we want to go from 5 to 1, decreasing by 1 step. So we need to check whether the range function will actually allow us to do that or give us an error. The easiest way to do that, before Googling or anything, is just experimenting. Let's see what happens if I ask Python to do this. Okay, not very helpful. Let's see if we say for x in range, print x. Uh, 5 to 10. Okay. From 5 to 1, it doesn't print anything because there isn't a range. It can't go all the way to 1 from 5. And maybe if we use a -1, things will be different. 5, 4, 3, 2. So once again, the last one serves as a limit, and the starting number is the one that gets printed as well. So now we know that it should go from starting number all the way to 0, because that way it will stop at 1 in steps of -1 number each time. And then for each number that we have here, we want to print 5, 4, 3, 2, 1. We want to print from that number all the way to 1. So we will say for z in range, a range that this time goes from x all the way to 0 in steps of -1, x 0 -1, it should print z And as we saw before, the end should be a space instead of a line break, as we saw in their solution here. And equals space. And with this, the print should be exactly the one that we want. Let's see. Nope. So we want okay, it's not happening because everything is ending in a space instead of a line break. So what we will do is we will add a print statement with 0 characters in it, and that should add the line break that we need, which is similar to what they did which is similar to what they did here with the print. No, I was wrong. Yeah, print. It's the same they're doing here. Well, it's too bad that this will throw an error because everything now will go in just one column. Yeah, that's absolutely right. I unfortunately saw the solution here. Because what happens is that after each number, no matter that it ended in a space, we are adding a line break here. So what we want to do is, after it has finished this loop, but before it starts the next iteration, we should give it a line break. And now we have exactly what we need. Exercise number 7. The solution is more complicated than ours. Let's see, n and k for I in range from 0 to n plus 1. Okay, from 0 to 6. And then for j in range from k minus I, yeah, so that's how they're reversing it, and it starts printing. Well, for obvious reasons, I like our solution better. Whew. So that was our session for today. We are still keeping everything very simple. As I mentioned at the beginning, I should have the video for the first step towards making our document generator up on Thursday. I'm thinking it'll take 2 or maybe 3 sessions to finish with that. And then, well, to be honest, I'm not really sure. What would you like to see? Is there any type of content you would like for me to tackle? If you have any idea, please don't be shy. Just write it down on the comments below. Don't forget to leave a like, a sub, a share. That would help me enormously. Thank you once again very much for joining me today, and happy programming!